Hey everybody, welcome back to the lab. We're now moving into a unit of the course about electricity. To start with, we're going to talk about a phenomenon known as static electricity. You've probably been shocked by static electricity before. One example where this happens a lot is on playgrounds, say after sliding down a plastic slide. You then touch something made of metal and it shocks you. In Physics 7b, we talked about electric currents, which involves electric charges moving from one place to another. However, in static electricity, electric charges are remaining in one place. Most of the time, objects that we come in contact with are more or less electrically neutral. However, it is possible to create an electric charge on an object such as this PVC pipe. The case of the playground slide should suggest to you a way to do this. It turns out there are certain materials that, if rubbed together, will transfer electrons from one material to the other. Let's see if we can do that here. Both of these PVC pipes are uncharged, as is this small piece of cloth. If we rub the piece of cloth on the PVC pipe, we're going to induce a static electric charge on the PVC pipe. Let's place this PVC pipe on here. What happens if I place this second uncharged PVC pipe next to this charged PVC pipe? Well, the answer is nothing. They don't seem to be interacting. Why might that be? That's going to be for you to figure out. But note that it has to do with the fact that one PVC pipe is charged and the other is not. But now we can charge this PVC pipe by using the exact same method that we used for the first PVC pipe. If we do that, we should see some slightly different behavior. Notice that the two PVC pipes are now repelling one another. They don't want to come in contact. Why? Well, it's because of their electric charges. What about this cloth? Let's pretend that this PVC pipe is positively charged. This would mean that the cloth pulled electrons off of the PVC pipe. But that means that the cloth should be charged as well. It now has extra electrons that it didn't have before. Let's see if there's a force between them. It may be a little hard to tell, but there was an attractive force between the cloth and the pipe. Why? It's very similar to the reason that there was a repulsive force between the PVC pipes. Let's look at one more interesting example. When we had one charged and one uncharged PVC pipes, we didn't see any force between them. But what about if we use this soda can? Well, first off, let's think about what might be different between a PVC pipe and a soda can. The material that this pipe is made of is known as an insulator. Electric charges are not allowed to move freely through this material. This means that once we create a static electric charge on this pipe, those charges are stuck. They can't go anywhere until they come in contact with something that they can move to. But this can is made of a metal, which is a conductor. In a conductor, electric charges are allowed to move around freely. Let's see what happens if we try the same experiment with this metal can. As before, we'll introduce a charge onto this PVC pipe by rubbing it with this cloth. And now let's see what happens if we bring it next to the can. As you can see, despite the fact that we did not give the can any charge, it still felt a force from the charged PVC pipe. Why did that happen? You're going to work out the exact reason in your groups, but it has to do with the fact that the charges in the can are allowed to move around freely when they experience a force. And where might they experience a force from?